Welcome to Tech Packs. In today's video, we're diving into an exciting project that tackles one of the most pressing environmental challenges, waste management. Introducing the Waste Collecting Robot, Smart Waste Segregation System. This innovative project aims to automate the process of waste segregation using a combination of sensors, a camera, and a robotic arm. The waste collecting robot is designed to identify and sort waste into biodegradable and non-biodegradable categories, ensuring efficient and eco-friendly disposal. As our world faces increasing waste-related issues, the waste collecting robot offers a glimpse into how technology can contribute to a cleaner and more sustainable future. Let's see the demonstration of our waste collecting robot. This intelligent machine is designed to differentiate between biodegradable and non-biodegradable waste and place them into their respective containers. Let's see how it works. As we place a plastic bottle in front of the robot, the ultrasonic sensor detects an object within its range. The camera then activates, bringing artificial intelligence and deep learning into play. The system quickly identifies the object as non-biodegradable. After identification, the robot picks up the plastic bottle and places it into the designated non-biodegradable container. Next, we present a cardboard box, which is biodegradable. The robot again detects the object using its ultrasonic sensor, stops, and the camera activates to classify the object. Once the object is classified as biodegradable, the robot approaches it carefully, grasps it, and deposits it into the biodegradable container on the right. Now, we place a tissue roll in front of the robot. As expected, the robot correctly identifies the tissue as biodegradable and deposits it into the right container. Finally, let's test the robot with a plastic bubble wrap roll. The robot identifies it as non-biodegradable and places it into the appropriate container. In addition to sorting waste, our robot is equipped with obstacle detection. If a person, wall, or any other object comes in front of it, the robot will automatically take a back step and adjust its path. Here, we simulate this by placing a hand in front of the robot. It detects the obstacle, moves back, adjusts its direction, and continues on its path. And there you have it. Our waste sorting robot efficiently and accurately classifies and disposes of waste, contributing to a cleaner and more organized environment. Thank you for watching this demonstration. Welcome to the journey of building our waste collecting robot. Let's dive in. We start with the basics, mobility. These are the wheels that will drive our robot, enabling it to navigate through various environments. Next up, the driving force behind our wheels. These powerful motors will ensure our robot can move smoothly and precisely as it carried its tasks. To secure everything in place, we have these sturdy clamps. They will hold our motors and wheels together, ensuring stability and durability. Let's go ahead and attach the motors to the clamps. This step is crucial for maintaining the alignment and balance of our robot. With the motors secured, we can now attach the wheels. Our robot is beginning to take shape. Now, let's focus on the gripper. This is the part of the robot responsible for picking up waste. We'll attach it to a servo motor, giving it the flexibility and control needed to grab different types of waste. With the mechanical components in place, it's time to bring in the electronics. We start by soldering the wires of our DC motors, ensuring strong and reliable connections. Our robot needs a place to store the waste it collects, so we'll create a container using a simple yet effective cardboard sheet. This will be the temporary home for the waste until it's properly disposed of. Next, we'll make some precise drills for the wires of our L298 motor driver and connect everything up. This motor driver is the heart of our robot's movement, controlling the speed and direction of the motors. Finally, we install the eyes of our robot, a camera mounted at the front near the gripper. This camera will feed real-time data to our deep learning model, allowing the robot to identify and categorize waste with high accuracy. And there you have it. Our waste collecting robot is complete and ready to make the world a cleaner place, one piece of waste at a time. Watch as it smartly identifies and sorts waste, making recycling easier and more efficient. Let's take a closer look at the components that make the waste collecting robot a reality. The heart of the system is the Raspberry Pi microcontroller, which manages all sensor inputs and motor controls. An ultrasonic sensor is used to detect objects in front of the bot. 4 DC motors control the movement of the robot's wheels, while a 5th DC motor operates the robotic gripper. Additionally, 2 servo motors are responsible for the precise up-down and left-right movements of the robotic arm. A camera is integrated into the system for waste classification using a deep learning model, allowing the waste-collecting robot to distinguish between biodegradable and non-biodegradable waste. And to power the whole system, we have used a power bank of 5-volt 2200 mAh battery. Here's the detailed circuit schematic of the waste collecting robot project. This circuit diagram illustrates how the ultrasonic sensor is connected to the Raspberry Pi to detect objects. The 4 DC motors are wired to the motor driver, controlled by the Raspberry Pi to navigate the robot. The DC motor for the gripper and the 2 servo motors for the arm movements are also connected to the Raspberry Pi, enabling the waste-collecting robot to pick up and sort waste accurately. Finally, the camera, a module, is connected to the Raspberry Pi for real-time image processing and waste classification. And to power the whole system, we have used a power bank of 5 volts 2200 mAh battery to make it standalone robot. Let's walk you through the code for a Raspberry Pi robot that detects and sorts biodegradable and non-biodegradable waste using deep learning and servo motors. We start by importing libraries like OpenCV for video processing, TensorFlow Lite for object detection, and GPIO for controlling the servos. We load TensorFlow Lite models to detect objects and classify waste, and we also load labels for these objects. The servo motors are responsible for picking up and placing the waste in the correct bins, and we categorize waste into biodegradable and non-biodegradable types. The functions close gripper and open gripper control the gripper's movements using GPIO pins. The put biodegradable waste and put non-biodegradable waste functions manage the positioning of the robot's arm and gripper to ensure the waste is dumped in the appropriate bin. We pre-process video frames with the pre-process frame function, and detect frame performs object detection using TensorFlow Lite. This involves classifying the detected objects and deciding where to place them. The object detection thread runs in the background, processing frames and detecting objects, while also using ultrasonic sensors to avoid obstacles. The process frame function takes care of sorting the waste by checking classifications and moving the robot to place the waste correctly. The find camera index function identifies the connected camera to ensure the robot uses the correct video feed for detection. In the main function, we set up video capture, start the detection thread, and process each frame until the program is stopped. This code enables the Raspberry Pi robot to autonomously sort waste into biodegradable and non-biodegradable categories, efficiently using a gripper and servos. In conclusion, the waste collecting robot, smart waste segregation system, exemplifies how technology can revolutionize waste management, making it more efficient and environmentally friendly. If you found this project inspiring, please like, share, and subscribe to TechPacks for more innovative solutions. Visit our website to purchase the complete package. Browse, select items, and click on Buy Now. Fill the required fields, then securely proceed to checkout, and you're ready to begin your project journey. Explore our site now to get started. Thank you for watching, and stay tuned for more exciting content from TechPacks.